But anyway, I hope you're all doing well.
And everything inside.
Yeah.
That's okay. Great. All right, let's just begin. So we looked at it. So just a quick recap on API gateway, right? So we looked at, and then I'll take advantage of this and then tell the difference between an API gateway. Even before we get to Route 53, right? The difference between Route 53 API gateway and then the load balancer. So let's start with the API gateway. So API gateway is that betweener, right? That guy who stays in the middle of the conversation. So chairman, I will indicate with C, right? Chairman is here at the end of the other side, okay? And then so the API gateway acts like chairman's follow back, right? So if anybody at all would want to have access to chairman, now you have to go through API gateway, right? And then you tell chairman that, hey, I need so normally I need money, right? So you need money from chairman. And then this guy will tell you, okay, wait, I they come. All right. So now API gateway will now go to chairman. All right, go to the service that you, whatever it is, what the back end, whether it's a Lambda function or what have you, go there, go and get the information, and now bring it here, and then now deliver the message to whoever is requesting. That is just what API gateway does. So API gateway proxies the connection. All right. If you remember when we did databases, we looked at proxies, right? The database proxy. So if there are plenty requests coming to, right, trying to access the server here, then the API gateway will be like, okay, you make a take all your message. Let me take all your message. I'll get the information from here and then deliver it to you. So the user is not directly accessing the server at the back end. So if it is a database or whatever, it is a form or whatever it is, the user is not getting direct access to it, right? The API gateway proxies that connection and then delivers to the client or the user, right? Or the customer. We looked at endpoint, the API gateway endpoint, right? We looked at the regional endpoint, right? And then the edge optimized. Now, the difference is that for the original endpoint gateway, the API gateway should be in the same region of your user. Now, the edge optimized takes advantage or uses or utilizes CloudFront edge locations, right? CloudFront is the service that delivers content to users at the edge locations. So the edge optimized endpoint takes advantage of the CloudFront edge locations and then deliver, or just to reduce latency. So with this, the APIs are edged or are placed at the edge locations, right? Or are cached at the edge locations. But then the API gateway itself sits in what? The US East 1. Okay? The US East 1. So it will depend on the question. So the user is using an edge optimized gateway. So I'll talk about the HTTPS endpoint. So API gateway supports HTTP, but then if you want to use HTTPS, then you will have to import a certificate, all right, onto the API gateway using what? The certificate manager, that is ACM, all right. So what happens is that if you are using an edge optimized API gateway, then your certificate will be installed on the API at where? The US East 1. Okay. But if it is original, then the certificate should be on the API gateway at the same region as your users. All right. So that is it for API gateway. So how is it different from Route 53 and then load balancer? So we are going to treat Route 53 today. But the difference between the API gateway and Route 53 is that now API, as you said, as the name goes, is for API. right? Calling API. So if you have a form, for example, we all use this thing. You use Uber, we use Bolt, right? You use Yango. Now the map there, the map is mainly another utility, right? So the map that you are able to see on the Uber app is through an API call. All right. You buy stuff, you order food online, you have to make payment, right? That payment, that resource that enables you to do that payment is as a result of an API call. So they have a payment processor, right? Maybe Hubtail, maybe Paystack, all right? Now, Paystack will provide when the company, so let's say Bolt Food. So Bolt Food registers an account with Hubtail or Paystack. Now, Paystack will give Hubtail an API to insert into the application code that will enable users to do payment either through mobile money or their credit card. All right, for the payment to go through, and at the end of the day, the amount is going to end up in their bank account. So, right, so the payment processor then is the payment option or the payment feature there is as a result of what? An API. All right. Now, Route 53 is for DNS. Okay. Now, what Route 53 does is that Route 53 server will be here. Okay. And then you have your application server. Let me clean this and then do it again. All right. So your user is here. Okay. Route 53 server is here. And then your application service or server is here with this IP address 1.2.3.4. All right. Now, Route 53 stays here. And then you will want to access the server 1.2.3.4. Now, what Route 53, there are a lot of things that goes on, but I'm just trying to explain this for you to understand, right? Now, what Route 53 does is that the user will now come to Route 53 and say, hey, I want to access this server 1.2.3.4. And then Route 53 being a DNS server, resolves DNS addresses, right? And then you have to register this with this. Now, Route 53 will say that, okay, I know where 1.2.3.4 is, right? There are a lot of processes that actually goes through, right? You have to go to the name server, something. So Route 53 will also go through different routes and then get the name before it communicates back to Route 53 or Route 53 to communicate back to the users. But I'm just trying to explain what Route 53 does. So after Route 53 has resolved all the name servers to get to know where your IP address is, Route 53 will say that, okay, I know 1.2.3.4, right? It is at this place. All right. And then, so the server will communicate, the server will communicate to Route 53 like this. And Route 53 will say that, okay, hey, I know this server. The server is at this point, right? So go here. And then it will communicate to the user back. And then now the user will now have the connection here. So your connection doesn't go through Route 53. Route 53 only tells you, so it's just like you asking for directions. All right. So Route 53 shows you the right direction to go. So next time, if I want to visit 1.2.3, right? If the customer would want to visit 1.2.3.4, the user will not go through Route 53 again. It goes straight, right, to the server. That is what Route 53 does. Load balancer, on the other hand, the same thing. You have your server here, okay? The user is here. So here, let's say we have like 3 users, okay? And then we have our load balancer here, this way. So if you front your application with a load balancer, so let me add like 3 servers, okay? You front your application with a load balancer. Then what the load balancer does is that, hey, I would want to access this server. So after you've gone through Route 53, so Route 53 can also be here, all right? Can also be at the top of your infrastructure, okay? All right. So I am accessing this IP address 1.2.3.4, and then with what Route53 also does is that it dissolves DNS name. So normally you are not going to actually like visit the IP address, but a name. All right. So let's say a.com. Okay. You want to visit this website, and then it is routing to a server called 1.2.3.4. All right. So that's what Route53 will do. Okay, I know a.com. A.com is on IP address 1.2.3.4, and it is on this server. So go to this server, and then that is it. All right. Now, here, the load balancer, we have 3 users accessing the same server. Now, the load balancer will come, okay, so you are coming, maybe go here, all right? Now, the second person will come and say, okay, one server is busy, okay? So if that is the case, then let me send your traffic here. This one also comes and said, okay, 2 servers are busy. So instead of you, instead of me overwhelming one server with 2 connections or 2 traffic, then you to come here, right? So if another user is trying to access, then it goes to the load balancer. The load balancer will route the traffic, right, to the server. So the load balancer is to balance the load. Okay, is to balance the load. So the load balancer is that guy who prevents mad rush. Okay, prevents mad rush. So okay, you go to banks, right? There are 3 tellers, but you realize that there is a lot of queue at one teller, right? They are also doing the same thing. So if that is the case, then Charlie, there are 2 more tellers there who have like less people they are serving. So some of you come here, another part also go here. So at the end of the day, they balance the queue so that if it has to do with everybody serving equal amount of, it doesn't have to be like equal number of people, but then it has to be balanced so that one person is not overwhelmed. So here you are accessing the server directly, but just that there is somebody here regulating, right, the traffic that comes in so that the service doesn't get overwhelmed and then at the end of the day crashes at the end. All right, so that is the difference between the Route 53, the load balancer, and then the API gateway. So that is just a summary. If anybody has a question, if not, we move to Rubicon. Right, then we'll move to the next agenda of today. And then once again, you people said Akosia's session was nice. You people understood it better. So Akosia will take us through Route 53 today. All right. And then I'll drop in once in a while if there is anything to add or clarify. Okay. So Akosia, if you're ready, you can share your screen. I'll stop sharing.
Okay. Good evening, guys. Please, can you hear me?
Yes, we can hear you.
Okay. So we're doing Route 53 today. Amazon Route 53 is a domain name service and a domain name system service, and that is responsible for translating domain names into IP addresses. So, for example, if I go to my browser and I type google.com, it takes me to this site, but in the computers, like in the language that the computer understands, the computer is using like numbers. So if I enter 172.217.18.36, takes me to the same google.com. So DNS system is what's responsible for translating the google.com I type into the numbers that the computer understands. And Amazon Route 53 performs health checks on 3 types of resources. So the first one is your endpoints, like your HTTP endpoints, your other AWS resources. And then the second one is other health checks. So in this case, you aggregate a number of, let's say, child health checks. And if a number of them are healthy, then the parent health check, which is representing all the other ones, is also deemed as healthy. And the last point, so you also perform health checks on CloudWatch alarms. And the use case for that is the health checkers are outside of your VPC. So if you want to perform health checks on your private resources, you're going to have to go through CloudWatch alarms. So if CloudWatch alarms is monitoring your private resources, we know we keep our databases like RDS and DynamoDB in our private VPC. So you have CloudWatch keeping track of the private resources, and then you link it with your Route53 health check so that if the CloudWatch alarm goes into alarm state, that shows that there's a breach or something is wrong and you can act on it. So a hosted zone is a collection of records, and we have two types of hosted zone. We have the public one, which resolves the DNS queries on the internet. And we have the private hosted zone, which resolves the DNS queries within your VPC. And a record is how to respond to DNS queries. It specifies how you want to respond to DNS queries. And inside a record, we have the routing policy, which we'll see right after this. We have the DNS value, which is the IP address. So as I typed google.com, it took me to 172.something. So the DNS value would be the 172 that it took me to. And the time to live also, when a user makes a request, a DNS request, and the response is going to the user, it goes with a TTL, which is the number of seconds that for those next seconds, if the person should go to that to try to find that same site again, the person is going to have the same response because the cache is valid for that TTL time that you set. And if it's for a CNAME or any other record types, you're going to have to set that time by yourself. But if it's an alias record, AWS sets it, Route53 sets it for you, and it's for a minute. And the record also contains a domain or subdomain name. In this case, in the example earlier, it was google.com. And your record has to also specify your record type. And we have A, quadruple A, or CNAME. There are other record types too. So the A is mapped to IPv4 addresses. The quadruple A is mapped to IPv6 addresses, and the CNAME is mapped to another host name. So looking at the routing policies show how the response is going to be given to the clients making the DNS query. So the first one, we have the simple routing, which is usually done on a single resource. So if somebody should query this particular DNS name, it should respond back with this particular resource. And the second type is the weighted route. Another name for the simple routing is round robin routing. And the second one is the weighted round robin. And for this one, you assign numbers weight numbers to your resources. So basically you have two resources, you give this 50, you give this 20. And when it is routing, it's going to send 20. So when it's routing, it's going to send more traffic to the 51 over the 21 because it's the individual weights you've assigned to it over the total weight. So it doesn't necessarily have to add up to 100, but the max of those numbers should be 255. And with the DNS failover routing, you would usually use this for active, passive, or primary, secondary architectures. So we mentioned that Route53 does health checks. So if you have two setups, and then Route53 checks the first one, and which is your primary or your active one, and the health check doesn't return as healthy, then it goes to your standby setup, which is also your passive or secondary So it starts getting responses from the secondary resource instead, because the first one is not deemed healthy. And we have geolocation routing. This one uses the user's location. So if you see a question, they would usually have like a specific location, maybe France or Germany or something. And that's how you know that it's likely a geolocation routing question. And geoproximity routing has to do with your resources, your AWS resources or on-prem resources, and the user's location. So that's the difference between the geolocation routing and geoproximity routing. For the geolocation routing, it's solely based on the user's precise location. That's how you set it. But with the geoproximity routing, you look at your resources and then you look at, it considers your resources and it considers your user's location too. And with the multi-value answer, that one relies heavily on the health checks. If a client should make a request, it's going to return up to 8 healthy records, and your client's device is going to by itself select any one of the healthy records to get their DNS response from. And with the latency-based routing, that is related to low response time. So you would see in the question that the creator of the app is trying to reduce the delay and the response that it takes for the clients to get the response. And this is usually done to improve the user experience. And the last type is the IP-based routing, and this is done with the user's IP address. So we did cider blocks with Isaac earlier. So if he sets the block and then he indicates that if the IP falls within this range, then it should go to this your resource to go and get a response. So if it's within that cider block, then it would go directly to it. And looking at the geolocation routing and the IP-based routing, there are similar concepts in AWS Web Application Firewall, which has to do with the IP match rule. So please, let's not mistaken the two. So with the Web Application Firewall, that works at the application level, layer 7. And the Route 53 works at the network layer, which is layer 3 of the OSI model. And the difference you see is that when it's in relation to the WAF IP-based IP match rule, is going to be like a security question. And when it's in relation to the DNS, it's going to be something that's about Route 53. And CNAME and alias records are examples of the record types that you can have in Route 53. So the two main differences between them is that the CNAME points the host name to another host name. For example, if I should go to my browser and I type search.google.com, it will still take me to google.com. And the alias points the host name to a specific resource. So it can point to your load balancer, your CloudFront distribution, your S3 website. And the second difference is that the CNAME works on non-root domain name. That is, we cannot use it on google.com. We would have to do it search.google.com. And the alias record works on both root and non-root domain names, which is, so it works for both search.google.com and google.com. So more details on alias is that it is free of charge and it's always either type A or type quadruple A. And as I said earlier, that could be IPv4 or IPv6 respectively. And alias records automatically recognize the change in the IP address of the resource. And alias records also has an inbuilt health check capability. And when you are setting a record for alias record, as I said, you do not have to set the time to live on your own. AWS is going to set it for you. But if it's any other record type, you're going to have to set it on your own. So some people would like to integrate their third-party domain registrar with Amazon Route 53. So a domain registrar registers domains. The popular one that we have seen is Wix, like how we used in foundations that we had to create websites on Wix. So let's say your Wix account, you want to use the domain name service that is Route 53 on your domain that you've registered on Wix. If you want to do that, you are going to have to create a public hosted zone in Route 53, and then you retrieve the name server records from there, and then you go to your Wix website and update the name server records on your Wix website with the NS records from the public hosted zone, because the public hosted zone works with how your DNS responses go on the internet. Yeah, thank you.
Okay, so that was very like do I say brief and detailed and short. So does anybody has a question? I have a few things to add though, but if nobody asks, then I presume everybody understands. So we just go with the information that we have. So if anybody has a question, kindly ask. You can put it in the chat.
What are some of the questions, like the use case questions we drop, like with regards to Route 53?
Okay, so kindly, I shall go to the routing. Great. So most of the questions we are going to see them around the routing policy and then the type of records. All right. So they would you might see a question like you have a 3-tier web application, right, with a load balancer, and then you would want customers to traffic to be routed to your load balancer, right? You are fronting it with a Route 53, but you would want the traffic to be routed to the load balancer. All right. Then in this scenario, so go to the records rather. Go to the records rather. So in this scenario, what do you do? So what you do is you set an alias record, right? You set an alias record to the load balancer. So anytime you are fronting your architecture with either a load balancer, a CloudFront, or S3, then you are looking at what an alias record. You can also see a question on the same thing, routing traffic to S3. Okay. Now you can't route traffic to an S3 bucket. Okay. You can't route traffic to an S3 bucket. You route traffic to an S3 website. So if you just have a bucket and then you have your HTML file in there, you can't just route traffic to the S3 bucket. You have to make sure that you enable static web hosting, right, in S3, and then you copy that endpoint address. That is what you set that the alias record to. Okay. So another one is also on the CNAME, right? So you have registered a website, something.com. All right. You registered a website, something.com, and then you want customers who would want to reach your server, right, routed to, let's say, I am searching.something.com. Okay. Then here, what you do is that you set what? A CNAME record. So you can't set a CNAME record for something.com, right? It doesn't work. So that's what we call root. So if you have a domain, google.com is a root domain. www.google.com is not a root domain. All right. So that is why when you just type google.com, it still takes you to, when you check the HTTP address, you see www.google.com. All right. So there is a CNAME record there. All right. So you can only redirect traffic like from you can set a CNAME record for a non-root account. So search.google.com, anything.google.com. Then you set a CNAME record to it. Okay. And rarely will you see a question on a quadruple A record. So quadruple A record is for IPv6 addresses, right? So mostly it's for the government organizations, the military, and then because of security reasons, right? It is difficult. It's an IP address that is like difficult to attack, right? So you have a company has an infrastructure and then they use only IPv6 address only, right? They would want to route. They want to they want the DNS to resolve like traffic to their IPv6 address. What do? Then you set up a quadruple A record. So you set up an A or a quadruple A record to an IP address. Quadruple A for IPv6 and then a single A for IPv4. All right. And I think there's also a question on hosted zone. So just like the scenario that Akosia gave, right? So you have your domain registered with a third-party domain registrar. So say GoDaddy, all right? But you would want to use AWS Route53 as your DNS host server. So what you need to do is that there is the Route53 name server has some name servers, right? For privacy reasons, I can't demonstrate that. So most of if you've worked as a hosting manager, or if you know anybody called like a position called a hosting manager, that's mostly what you do. All right. So what you do is that you go to your third party, so say GoDaddy, and then there is a portion called, like, you see a name server there. All right. And then you take the name server record. So you probably see ns.amazon.com.something something. So you have like 4 different addresses. All right. And then you go to your third party domain registrar, and then you input the Route53 name servers DNS addresses there. All right. Then Route53 now becomes your DNS host server. Okay, so there is a difference between a domain registrar. So you can just buy a domain name from anywhere, and then you can and then host it somewhere else. All right. So that is also another thing that the question can, you have a third party domain registrar, but you would want to move it. So what you do is that you just update the name server records. You update the records on the website with the third party registrar, and then you are good to go. All right. So the difference also between the public and then the private hosted zones, it just has to do with the resources. All right, the resources that you have. If it is a website, then you have to set a public DNS zone for a public hosted zone. Sorry, all right, so it's just a collection of records. So in a hosted zone, you can have an A record, you have a CNAME record, you have an AAA record, you have there are a lot of records, a text record, and then all that. All right, that is where you set them. So that is for the public resources. And then if you have just resources within the VPC that you would want to like reach them via a DNS name instead of the IP address, then you do a private hosted zone that is just accessible to you within your VPC. All right. So let me explain time to live. All right. So time to live is basically just updating your web address. So most of the times before you put out a website, you would want like possible combinations, right, of addresses that you can use to reach your server. So let's say I route traffic to IP address 1.2.3, right, .4, and then I update my server. So this time I would want the traffic to be routed to 5.6.7.8. Then, but if the time to live, right, on the record is 24 hours, then it means that it has to take 24 hours, right? It will take 24 hours before, if anybody visits maybe my website.com, they will be routed to the IP address 5.6.7.8. Okay, so most of the times the trick that people use is that anytime you want to update your records, right, you reduce the time to live to a very short period. Okay, so after that time, when it is updated, then you increase the time to live, just to say, because for every query you pay, right? So just to reduce the cost. So okay, so let's go to the routing policies, then I will explain as well. All right. So I was expecting like questions from here, but it looks like I see. All right. So the round robin is just the concept that I explained. Okay. Can I pull up the annotation while somebody else is sharing? I should be able to do that because somebody else did it. Somebody is able to write on my screen.
Yeah.
Principal, you do how you do.
Okay, it's working.
He did a screen too.
I see for you. All right. So the round robin is just like, okay, hey, I want to access a.com. Okay. I want to access a.com. Where do I see it? So Route 53 will now go to server A. Server A will tell, so let's say this is server A. Right, server A will tell it that, okay, I don't know a.com, but I know .com. All right. And then .com can be located at on this server. So Route 53 will go to this server and it'll be like, okay, yes, I know. So it's like a lot of things, right? So okay, so I know a.com. All right. And then now a.com is on server 1.2.3.4. Okay. So something like this. And then now this information goes back. So like this. Okay. All right. And then now Route 53 will now communicate this to the client. So that is just the round robin thing. Okay. So it's just go for the information and then bring it, all right, to the user. The weighted is just weight. So as I said, it's up to, like, the number is not up to 100. Is how much? I think 255 or something. You mentioned it. Yes, 255, right? So it's not about percentage, but you are just saying that, okay, take this chunk percentage or this amount of load. So if you have two servers, right? Yeah. Right. And then identify that, okay, send 100. It doesn't mean send 100% of the load. Okay. Send 100 of the load to this server. Okay. And then send, let's say, because the total is 255. So send 155 to here. All right. So it means that this server will receive more load than this. That's just the weighted round robin. All right. And then the DNS failover, that one we understand. You have two sites, okay, with health checks on them. Okay, so Route 53 is here. Okay, so immediately this one fails, it's switched here. This one comes back, and then this one fails, it's switched here. That is just the DNS failover thing. So if you see active, passive, primary, secondary, that is just it. All right. So you have, they will tell you have a multi AZ or multi-region. Most of the time it's multi-region architecture. All right. And then you have Route 53. So how do you, I mean, for disaster recovery purposes or for high availability, how do you make sure that the system is able to withstand failure? All right. So if you have Route 53, then you set up what a failover routing onto the secondary site or secondary infrastructure. Okay. And then for geolocation, I think it was straightforward. So geolocation has to do with the location of the people. So if I have 10 servers, I can even have, so for example, I have a server in the UK. All right. So ideally, I should route traffic that is coming from, let's say, all of Europe. So anybody that is within Germany, anybody that is within what? Momobobo, all the European countries, right? Italy and then all that should be able to reach the server. But I can say that now, if you are in Asia, all right, routes all Asia traffic to the server in UK. That solely depends on you. All right. And then let's say this one is in Africa, but I want people in the America or in the States, all right, to be routed to the server in what? Africa. That depends also. It's mainly on your location. And then the geo proximity. So there is what? Geolocation, and then there's proximity. That one has to do with your the location of your user and your server. All right. So you route the traffic based on their proximity to the resource. Okay, so that's geo proximity. So if you have a server in Africa, you have a server in the UK, then with geo proximity, it says that, okay, somebody is within, no, let me use, so here, Africa and this place, Latin America, where the Brazil, the Caribbean, all right. But then, if you know this person is in the Caribbean, but it is closer to the African border, so then traffic will be routed to the server in Africa instead of what? The server in America. All right, so that is it. So consider the resource, the location of the resource, and then the resource of the location of the client as well. Okay, and then for multi-value, it's mostly.
Sorry, I beg.
Mhm.
So for, geo proximity, does it have to do with latency?
Yes, it has to do with latency.
Okay, so geolocation doesn't necessarily deal with latency. It
No,
just
no, no.
deals with
It's just how you specify it. All right.
okay.
So and then your proximity has to do. It takes let me say distance, right, instead of latency, because there is also latency based routing. All right.
Mhm.
So it has to do with like, so for your proximity, it has to do with just like how close you are to the server. You get it? Because
Okay.
Africa per se, even though we are close to, no, let's say we are even the same time zone with Europe, especially the UK. But normally when you check for latency, I think it takes us to I think France or so. You understand? Like that is where if there are servers, there is like low we can experience like low latency there. Yeah. So geo proximity just has to do with distance. All right. Great. And then there is also the multi-value answer. So for the multi-value, you feed the record with like, let's say three IP addresses, right? So you have 1.2.3.4, we have 5.6.7.8, right? And then you have 9 dot this, this, right? So you have three records in there. Now you are routed based on how healthy the server is. Okay, so if you have, let's say, when it came, if they are all healthy, then all will be fed to the client requesting that address. So just like our Akosia did, www.google, or let's say google.com, right? And then Route53 presents that, okay, I have these three records, and then the browser itself will choose one, and that it happens like very fast, so you don't see it, but those are the things that goes on like in the background. All right, then you choose one, and then in case, so if let's say this one goes out, then the person, your browser will be presented with two servers for it to for it to choose one. And then there is the latency based like routing, right? That has to do with like low latency. So how quick it can reach the server. And there is also IP based routing. So that one you specify a CIDR. You say that, okay, anybody with the address, like an address range between, so from 1.0.0.0 slash, let's say, 16. Okay, so you say that any address that falls from within 1.0, like from 1 to 255 from here, and then 1 to 255 from here, should be routed to maybe server A. Okay, and then again you come to 1.1.0.0/16 should be sent to server B. So you are just specifying IP ranges, so it doesn't matter where the person is. As far as the IP address falls within that range, then they will be routed to the respective server. So that is also with IP based routing. Okay, so you just have to like have how these things work, like on a high level, and then how they work well, so that however the question is put, you are able to get to answer it. And if there are no more questions, we're about closing. But somebody just shared something in the main WhatsApp group, so I think it is very important that we look at it, how AWS, how the grading is actually like. All right, so you know how IELTS and then all those things are are graded. It is not like mainly based on the number of questions you get correct or you answer correct. You understand? They take into consideration how difficult the questions are. So I'm sure that is why this time your result is not like giving you, because there's a lot of like, they have to take into consideration a lot of factors. So there might probably be like some manual efforts in there, or probably there are systems that checks those things, right? So IELTS that's because the questions are randomized, right? And they are from a question bank. It is not the same set of questions. So definitely somebody might have a difficult set of questions, because even though there are domains that are specified in the exam, but it could be that your set, you'll be only tested on just 2 domains, right? Somebody might go and then they will have all the 4 domains in there. So a person like this, it will be unfair, right, for that person to be graded on the same scale as what's it called? As anybody else. All right. So I just read it. It's from the AWS websites themselves. All right. So I just read it. So that is how it is. So if you should get like 836, all right, your total mark is 836. It doesn't mean that you answered 83.6% of the question correct. All right, you probably answered just 40% of the question correct. Right. Probably just ended, but then based on the difficulty of the question like carried more weight, right? So it is important. Am I on?
The network go well.
Is it?
The network went off.
Wow. So where did
You
I
ended
break?
at 896.